While it is well known that ray tracing impacts GPU performance, leading to the inclusion of dedicated units in modern GPUs, the effect it has on CPU performance is often overlooked. In this video, we'll dive into CPU side cost of ray tracing, explaining why it occurs, how it works, and how understanding these details can help you optimize in-game settings. Hello and welcome back to Hardware Lab. If you are a regular viewer of Hardware Lab, you are likely familiar with the concept of BVH or Bounding Volume Hierarchy structures in ray tracing. Essentially, a BVH buffer is a simplified representation of the in-game environment that the GPU uses to trace rays more efficiently. The process begins with a broad box representing an object in the game, which is tested for intersection with a ray traced from the camera. If there is a match, the box is subdivided into smaller boxes, each of which is tested again. This continues until the ray intersects with an actual object's triangle at the set quality level, though this quality is typically lower than the in-game geometry. The ray then bounces, repeating the process indefinitely or until it reaches predefined limits. All of these ray box and ray triangle intersections are managed by the GPU's ray tracing units. However, BVH structures don't generate themselves. They need to be created and updated articulately when objects in the scene move or change, as well as every new frame. This task falls mostly on the CPU, and it's this additional workload that contributes to the increased CPU demand when ray tracing is enabled. The CPU constructs and prepares the BVH structures for the GPU, which leads to more draw calls. You can think of BVH as an extra layer of geometry that the CPU needs to manage on top of the main game frame. But just how significant is this effect? That's what we are about to explore in our test. For this test, we are using a Ryzen 7 5700X3D with 2 cores disabled, making it closely comparable to the upcoming 5500X3D, with the only difference being a slight 50 MHz clock speed variation. Basically, it's a 5500X3D. It is paired with 16GB of 3733 CL15-16-1636 DDR4 RAM and Radeon RX 7800 XT. All the benchmark runs are recorded using Radeon Relive, which can impact CPU performance, so keep in mind that these recordings are primarily for showcasing the system's behavior, while the precise performance metrics gathered during separate runs will be presented at the end of each test. Callisto Protocol is one of the most CPU demanding games in terms of ray tracing I have ever seen. The game without RT is generally light on CPU, but with ray tracing it becomes extremely demanding. This game's CPU performance drop with enabled RT is not as dramatic, but still very noticeable. Where the drop is dramatic is in Spider-Man Miles Morales. Ray tracing in this game is extremely CPU heavy, although it can be reduced, but more on that later in the video. Forspoken is a pretty light game on CPU in general, no matter with or without ray tracing, but the difference in performance is still there, although it's not that big. Another minor but noticeable performance drop on the CPU side when enabling ray tracing can be seen in Guardians of the Galaxy. Lad, if you're watching this, congratulations on a successful launch and thanks for the benchmark. But it has one problem. This particular moment freezes no matter what, ruining the 0.1% stats on any hardware or settings. Vladimir uses a pretty much stock Unreal Engine for ray tracing as far as I can tell, and it is extremely heavy. Not only is it heavy on GPU, but on CPU as well. Enabling RT cuts the performance by half. The same thing we've seen in the Callisto Protocol. Gotham Knights is known for pretty poor CPU utilization and heavy ray tracing at the same time, and honestly, I don't know who might want to play with enabled RT considering even 5500X 3D can't provide 60 FPS without significant drops below. Yes, this game is heavy on CPU even without RT, but nowhere near to that extent. At least it is way easier to control the vehicle. Returnal runs somewhat slower with enabled ray tracing, but I'd say the drop is not that huge, considering other Unreal Engine 4 titles tested so far. Almost no impact of ray tracing on CPU performance can be seen in the first Descendant tested in the hub. This may be related to the medium ray tracing settings chosen due to a GPU limitation on other presets. Medium RT in this game seems only to enable RT reflections that can be seen here and there, but I doubt it generates BVH for the whole scene in this case, since most scenes seem to lack the effect at all. And yeah, freezes permanently happen in the Players Hub location, again ruining the 0.1 stats. This game's ray tracing impact on CPU is comparatively low in terms of overall performance, but pretty strong on frame time stability. This is related to the way ray tracing is implemented. While the main game runs on DirectX 11 API, the ray tracing effects use Vulkan, and cross-API communication reduces stability. Overall, there are very few games where the impact of ray tracing on the CPU is minor enough to be ignored. In many cases, the performance hit can be substantial, and in some instances it's surprisingly severe. The effect can range from almost negligible to cutting CPU performance by more than half when ray tracing is enabled. This makes it crucial to always consider and test how ray tracing affects CPU performance on game-by-game basis. Okay, now that we understand how significant the impact of ray tracing can be on the CPU, the next question is which ray tracing settings affect CPU performance, And can we reduce the RT quality to improve performance? The answer isn't as straightforward as you might expect. Remember, the CPU's involvement in ray tracing mainly comes from building and updating the BVH structures. Now consider this. The GPU has to trace rays through the same amount and quality of structures, regardless of the specific RT effects you add. For instance, if you start with RT reflections and then add RT shadows, the GPU workload increases because more ray tracing is involved. However, from the CPU's perspective, the volume of BVH structures that needs to be updated and generated remains the same. So theoretically, this scenario shouldn't impact CPU performance. Let's put this to the test by examining some games that allow us to toggle different ray tracing effects individually. In this test we have three different scenarios: ray tracing disabled, some ray tracing effects enabled, in this case just lighting, and more RT effects enabled, in this case both lighting and sun shadows. As you can see, enabling two RT effects puts more strain on the GPU, which is reflected in the GPU load monitoring. However, because we are CPU limited, and the BVH quality remains unchanged, the FPS stays the same across both ray tracing scenarios. The same behavior is evident in Miles Morales. Whether you enable both shadows and reflections or just reflections, as soon as any ray tracing effect is turned on, CPU performance remains unchanged. The final game in this test confirms the results. No changes to the BVH structures mean no changes to the CPU performance. So does this mean that ray tracing's impact on CPU performance will stay the same regardless of the RT settings? For some games, yes. If the game menu only offers options to enable or disable specific RT effects, any combination of those effects likely won't make a difference. As soon as one effect is enabled, the BVH structures are built and their quality typically cannot be adjusted. However, some games offer ray tracing quality settings, which may or may not affect the BVH. For instance, a quality setting for reflections might only alter the resolution of ray traced reflections, making them sharper or blurrier. Or it might remove some objects from the BVH. In the first case, changing this setting won't impact on CPU performance. In the second, it will. Let's test some games that allow BVH quality adjustments. Remember how fully disabling shadows didn't change the CPU performance in Miles Morales? Well, changing the reflections quality and object range while leaving shadows enabled changes the FPS significantly. The same pattern is noticeable in Crysis Remastered. Switching between quality presets changes the BVH quality and impacts CPU performance, although the effect is less consistent and may be absent in some scenes. Overall, it's clear that the only way to prevent a significant drop in CPU performance when using ray tracing is to lower the settings that control BVH quality if those options are available in the game menu. I honestly don't understand why so many game developers provide such limited ray tracing settings in their game menus. In my opinion, Spider-Man Miles Morales does this best, while games like Gotham Knights with their simple on-off option for plenty of different effects do the worst. Yes, settings like BVH geometry quality and BVH geometry range might sound confusing to some users, but that's why you can offer ray tracing presets for those who don't want to dive into the details and include explanations like the ones in Spider-Man. Thanks for watching. I hope this video has helped you better understand where the CPU load with ray tracing comes from and how to reduce it. If so, why don't you consider liking this video, subscribing, ringing the bell, and as usual, stay up to date with HL.